Okay, so the 9.1 to 9.4 test, which is tomorrow, you can use scientific calculators on. You don't need them, but obviously when you're doing something like 62 square root 3 times square root 3, it's going to be easier to do that on a calculator than it is going to be by hand. No graphing calculators, no sharing, no nothing. So if you don't have one, you're going to do without. But obviously I'll allow it, so I would encourage it. So 9.1 was on your quiz. It's a good way to review. Look back on your quiz. Anything that's on there would be fair game again for your test. It was circles and parabolas. So the circles, really all you needed to know from the circles was the equation x minus h squared plus y minus k squared equals the radius squared. The h, the k is your center. And the r is your radius. So we had two different types of questions with this. One was complete the square, and then from that determine your center and your radius. And then the other where you were given either the endpoints of the diameter or the center and a point on it and asked for the equation, okay? Example of those are on your quiz and in the review. Parabolas, there's two equations. One for a vertical parabola, which would open upwards or downwards. That's the x minus h squared equals 4p times y minus k. And then the ones that open right or left, y minus k squared equals 4px minus h. So the difference there being for the open up and down for the x squareds, the 4p term is going to be positive. So this one, that would be a positive, and this one, that would be a negative. And then for the the horizontal one, this 4p is going to be positive if it opens to the right and negative if it opens to the left. So just like circles, parabolas, two different kinds of problem. One in which you get the equation and you've got to take the information out of it, possibly graph it. The other where I give you the information, like you're going to either have the focus, the vertex, or the directrix. Two of those three pieces of information, and you've got to get the actual equation. So if it's a vertical parabola, remember the focus falls inside the curve. The directrix is the same distance away from the vertex as the focus. And this distance here is P. So that would be P and that would be P. Same thing if it's turned on the side.
The directrix is defined as y equals or x equals and then the number?
Correct.
And it's, like, mentally you think of it opposite, so if it's
Yep.
y equals, it would be, like, on your x, and if it's x equals, it would be on y.
Correct, because it's opposite your axis, right?
Okay.
So it's always, if your parabola is turned facing the side, then it's the directrix would be a vertical line, and a vertical line is an x equals.
Okay.
Yep. So if you're saying it's whichever one is not squared. So if the y is squared, it's an x equals. If the x is squared, it's a y equals.
That's a way to remember.
Okay.
Thank you.
You're welcome. And again, the point, focus, the point would be obviously a point. The vertex would be a point. Directrix is a line. Okay. You're going to get given two of those three pieces of information, and then from there you got to figure it out. Okay. Again, that was on your quiz. 9.2 was also on your quiz. This is your ellipses. So a horizontal ellipse means that it is wider than it is tall, and a vertical ellipse means that it is taller than it is wide. Don't take a picture yet because I'm going to add to that. Yeah. The horizontal is x minus h squared over a squared plus y minus k squared over b squared equals 1. Vertical, x minus h squared over b squared plus y minus k squared over a squared equals 1. So what's the difference with the a this time? With ellipses, the a is always the bigger number. So a squared equals larger number, okay? Which is different when you get to hyperbola, right? So the larger number is under whichever axis would be wider. So if the larger number is under the x, then it's wider. If the larger number is under the y, then it's taller, okay? So for here, you have things like your center, which is your HK. You have your vertices and your co-vertices. So your vertices, if it's vertical, you're adding the a onto the y value and keeping the x. If it's horizontal, you're adding the a onto your x, center and keeping the y. And the co-vertices is the opposite. So if it's horizontal, you're adding and subtracting the b onto the y. And if it's vertical, you're adding and subtracting the b onto the x. So that's the co-vertices. So vertices gets the a, co-vertices is the b, and the last thing is the foci. And that's where c comes into play. So the foci lies along the major axis. The foci, if it's a horizontal one, you're adding the c onto the x. And if it's vertical, you're adding the c onto the y. And the relationship between c squared and a squared and b squared in the ellipse is what?
C squared equals A squared minus.
Minus. It's the opposite of what your initial equation. So, right, ellipse is a positive in between the two in between the two fractions, but between c is a minus, and then it's the reverse for a hyperbola. Okay, and then just like parabola, make sure you know how to get from an equation to a graph of an ellipse and the information out of it, center, vertices, foci, all that stuff. Or from the information, whether it be the vertices, the co-vertices, the foci, the major axis and the minor axis. So the major is 2A and the minor is 2B. They're going to give you some sort of information enough to get you to the rest of it for the ellipse. Yep. The x, like, always go first, you mean? It doesn't really matter because it's a plus. As long as the bigger number's under the correct one, as long as the a is under the major axis. So if you're creating the equation, the order doesn't really matter because it's a plus. Yeah. Okay, then hyperbolas. So that was where the quiz ended, and then since then is new material, right? So the hyperbolas, classification, and the rotation are all in 9-3. That's why we divided it into 2 days. The hyperbolas, if it's horizontal, so these are the ones that would have faced outward, had x minus h squared over a squared minus y minus k squared over b squared equals 1. And the asymptotes here are y equals k plus and minus b over a x minus h. That's for horizontal. And then for vertical, so these faced up and down. This was y minus k squared over a squared minus x minus h squared over b squared equals 1. And the asymptotes are y equals k plus and minus a over b times x minus h. How do I know if it's vertical or if it's horizontal?
With the A over the B over A.
Where's the a?
A would under the X.
A is always first. Yep. A is always first. So if it's an x minus a y, then the a is under the x, and it's horizontal. If it's a y minus an x, then the a is under the y, and it's vertical. This time, c squared equals what? Good. A squared plus b squared. Remember, it's the opposite of the standard format. So if it's a hyperbola, the standard is x squared minus y squared, and the c is plus, and the reverse for the ellipse. So again, you've got something for a center, vertices, and foci. Center is your HK. The vertices, you're going to take and add and subtract your A from the major axis. And the foci, you're adding and subtracting the C from your major axis. And then to get the little box, so the co-vertices, you're adding and subtracting the B from your major axis.
For the asymptotes, I know we have to probably figure it out.
Mm-hmm.
But do we have to graph it correctly?
No, you can use a little box. So if you're given the information, let's say you're given and you have to get the equation into standard form. So complete the square, get it into standard form. Now it's in standard form, and then graph it. So from there, you'd pull out your center, you'd get your A, you'd get your B. You can draw yourself your little box, draw the asymptotes, and then draw the curves. It will also ask you for your asymptotes, so make sure you also know how to get the equation.
Okay.
So on a question that is, here's the equation in non-standard format. It's complete the square, leads into the standard format, center, vertices, foci, asymptotes.
Okay.
Isabella? You can do the co-vertices just to get the box, but I didn't give you a line to give me the answer for the co-vertices on the hyperbola. I did for the ellipse, but not the hyperbola. Yep.
Again, like for vertices, foci, and vertices, it just depends on if it's horizontal or vertical. Or
Correct. So you're always adding A for vertices. The difference is, are you adding it onto the X or to the Y?
Okay.
Right? So if it's horizontal,
Yes.
then I'm going right and left the A, which means I'm changing the X.
Okay.
If it's vertical, it means I'm going up and down the A, which means I'm changing the Y.
Okay.
Does that make sense?
Yeah.
And then the reverse for the co-vertices.
Yes.
Foci always matches the vertices. So if it's horizontal, I'm counting out to the right and left the C,
Okay.
and up and down. If it's vertical, up and down the C.
Okay.
Yep, for the foci. All right, and then same thing, hyperbolas. Here's the equation, give me the information, or here's the information, give me the equation. So again, you can have major axis here, which is 2a, and minor axis, which is 2b. That doesn't change.
That's the length of the entire, like, yeah.
Correct. Think about when you find your center, you go up and down the A or right and left the A, so the actual full axis would be 2 times A.
And that's important to know, like, if they do give us the length of the...
Right.
What we're trying to
I'm not going to
see.
ask you for it,
Okay.
but if you could get given it in order to find the information, to find the equation.
Okay.
Yep. Questions on hyperbolas? Okay, we did classification. So I want to be really clear because on the initial slide where classification was, there was a b, like when I was showing you the actual formula for how to find the a and the b, there was a bx squared, xy there. But classification doesn't work until you get rid of an xy. So when I ask you the straight up question of classify, there will be no xy term. I'm not trying to trick you. But if you want to classify your rotation of your conics, you can't classify it until after you eliminate the b term. Does that make sense? So you need it in standard form first. So if the question is classified, there will be no bx term. I'm not there to trick you. And then in that case, if a equals c, what kind of conic is it? Circle.
Pardon the interruption, but Taylor...
If a times c is 0, what kind of conic is it? Parabola. That means one of them is missing, right? If you only have one squared term, it's a parabola. If a times c is bigger than 0, ellipse, good. And if a times b is less than 0, hyperbola. So yes, there's a question on just classify it. Okay? Make sure you know it. That's a silly question to get wrong, and when you get it wrong, you get it really wrong. There's no such thing as partial credit, right? It's not like, oh, there's an E in both of those letters. Let me give you some partial credit. That won't happen. Okay? Yep.
Do you think we should memorize, or because like sometimes for me it's just easier to actually like...
It doesn't matter how you do it.
Okay.
Yeah.
With these, like, where do you get the A's?
The A is in front of the x squared. The C is in front of the y squared.
But it's only if X, Y is eliminated.
Correct. So on the classification question, there's not going to be an XY. If you wanted to try to classify your rotation so you know what it looks like at the end, you can use this method, but you can't use it until after you eliminate the XY.
Got it.
Does that make sense?
Oh, so this will help figure out, like, if you...
What kind of graph it is. After you eliminate the XY, though.
Oh, so after you, like, plug in everything, and then you're about to, like, figure out what you do, the X,
And you're like, is it a hyperbola? Is it an ellipse? Or is it a parabola? You can use this method to try to figure out which one it is.
That's good.
Okay? That's good. I like it. Good. Okay. There's a purpose to this. That's always a good thing. Okay, then the rotation of the conic, and I'm not going to work through an example because it will take the rest of the day, and I'm tired of doing them just as much as you guys are tired of doing them. There's like 6 videos of rotation conics. The part 2 of 9.3 has a rotation of a conic on it. The warm-up from the next day has a rotation of a conic and an extra example. The review from Friday, which has 62 from your book, has a rotation of a conic worked out. Okay? And then I have done the 6 on all of your tests, and I don't want to do anymore because I'm going to have to do them for the makeups. I'm done with the rotation of the conics. So you can go to find a video of me doing them all those other times because think every time you've seen it, I've done it 3 times that day. I'm rotated out. So you're going to first find theta, okay, by doing the cotangent of 2 theta equals A minus C over B. You're going to actually get theta from that. That's going to get you like maybe 2 points. I gave you what x equals, which is x prime cosine of theta minus y prime times the sine of theta. I'm giving that to you directly on the test. X sine theta plus y prime cosine theta, okay? It's the only thing you don't have to memorize. That's going to be on your test. Once you get that, which will get you some points if you get it correct, obviously, then you're going to plug those back into your original equation, expand it. You're going to be foiling. You're going to be using one of those shortcuts. Make sure you practice it. And then you get to your ending equation that you want to put into standard form. Then you want to rotate your axis. And I'll give you a hint. It's probably going to be a pi over 4 or a pi over 6 because those are the only ones that we can totally do without the unit circle outside of the first quadrant. And then graph your function after that. So again, there's a million examples.
30 degrees, right?
Pi over 6 would be 30 degrees, yep.
What shortcuts were you talking about?
Like if it was something, so if I had x squared, right, and my x is root 3x plus y, these are primes, over 2, and I take that and I plug that in. So you square the first term, you square the last term, and the middle term's the product of the 2. Or the xy, if you have a 45 one, where 1 is this. I took out the primes, but you would bring them back in. This is the difference of two squares, right? It only happens on the pi over 4. But if I get a pi over 4 and I have an xy term, then I can just do the square of the first term and the square of the last term, put a minus between them because they're the same. But once, yeah.
Yeah, because they're like normal.
That's the same function, right? Root 2x plus root 2y and root 2x minus root 2y. If I FOIL that out, the middle terms are going to cancel out. Only happens on a pi over 4 and only on the xy term. But you can use that shortcut. Okay. You can lose the primes as you're working through. Just make sure I literally gave you a space that says theta equals blank, x equals blank, y equals blank. Somebody's still going to make a mess and try to circle the answers and piss me off. Don't do that. Try to get it on the lines. And then it says equation equals blank. This equation better have your primes back in it. Okay? So you can lose them while you do the work, but when you give me the answer, that is not the same equation as the one in the top. We eliminated a variable. We changed that equation. We rotate the axis to make up for it, so when we graph it, it's right. But you're changing the equation, so you can't lose those primes all the way through. Yep.
Are you actually going to graph it? Or
Yep, and then you're going to graph it. Yep.
And so if it's like the theta is pi over 6, do you move that to the left?
Yep, so if my theta is pi over 6, then your graph, which is going to look like this, will get rotated to pi over 6. And your graph, whatever it is, let's say it's a hyperbola, is going to be rotated on that axis. If it was pi over 4, it'd be rotated up to pi over 4. And if it was a parabola or a hyperbola or ellipse, you'd...
And you're giving us that.
Yep. This one's a big one, okay? So it's the last one. I did it like that for a reason, so that you can make sure that you get through the rest of it and leave yourself the time at the end so you don't get stuck on it and not give up. However, I'll give you a heads up, like I would not leave less than 15 minutes to work on this question. Yep.
Wait, what?
She said I'm giving the x and the y, this thing I'm giving you on the test. Yeah.
Yeah. Sorry, I thought you meant like
The actual equation, that's the hyperbola, the ellipse, the parabola, that's the equation you want?
Yep.
In standard form?
Yep. So it would say something like the ones you've had said like x prime over 2 plus y prime over 16 equals 1. That's the standard equation I'd be looking for.
And are all the numbers going to be like that, like whole numbers, or is it going to be like a fraction?
They're whole numbers.
They're whole numbers.
They're not always perfect squares, but they're whole numbers.
So it's not going to be like a funky like 3 over 18
No.
where I'm going to have to do 18 over 3.
No. No. And then the last section was the parametric, and there's 3 different types of questions with the parametric. The first is where you're given 2 equations. I'm just going to make something up. I'm not going to actually work it out. And you had to do your t-chart, the t, the x, the y, and the xy. I actually drew a t-chart out for you and gave you a restriction on the t so that it's super easy for me to grade, okay, because they should all look the same. Biggest thing I would say here is be careful. Make sure you put your arrows on your graph. That's where people forget stuff. So if I were to plot this point and I would graph it out and it looks like a line and it starts here and it ends here, then my arrows need to be on my line. So if it said plot from -3 to 1, you'd have -3, -2, -1, or -3 to 0. I'd plug those into the x, get that. Plug those into the y, get that. And then you'll give me the 4 points, and then you'll plot the 4 points and put the orientation on the graph. Maddie?
So we don't put the arrows like after the start and end point?
No, because I'm restricting it. I'm telling you only graph from t being this to this.
How do you know where the arrows go?
They point towards the largest t. So it will go from this point to that point. So if that means the last point is all the way to the right, that means that's where your arrows point.
So what is the restriction for that look like?
The restriction would be this, like -3 is less than or equal to t is less than or equal to 0. Not domain restriction. That kind of, yeah.
So there's gonna be 3 questions on this test pertaining to 9.4.
Yeah, there's 3 different types, yeah.
Could you go back to the classification?
Okay, then I don't know the order of this on the test. I know all 3 of them are on there, but I can't off the top of my head tell you what order. 1 was the t-chart, 1 was eliminating. The 1 is eliminating the parameters. So in this case, you would have something like a y equals 3t plus 1 and a y, or an x, sorry, equals 4t plus 2. The goal is to get rid of the t. So you solve one of the equations for t, plug it back into the other one, and you end up with 1 equation with no t. That's eliminating the parameter. And then the last one from 9.4 is finding the x equals and the y equals from two equations. One will have, like, let's say it's t plus 2 and y equals 3x plus 2, something like that. One's going to have a t, one's not going to have a t. So this would be my first equation. You might have to solve it for x, but it would be your first equation. And then I would take this and plug it in the place of the second equation so that that had a t, and that would go there. So those three types are in the notes for 9-4. That's what your homework covered on 9-4. Okay, that's what will be from 9-4. Yes?
For eliminating the parameter, you're going to have one that has a T and one that doesn't.
For eliminating the parameter, they both have the t. You're getting rid of the t. So
Your
you,
final answer.
oh, your final answer is one equation
Yeah.
with no t.
Because you're combining the x and
Yep.
the y together.
So this gets into one with no t. And those are the ones that we graphed to estimate. I'm not having you graph it because you have like 5 other graphing questions, but that's where you would get it from. Olivia.
So for this, the x equals t plus 2.
Yeah, I mean, it's probably not going to be that easy. You'll probably have to solve for x first and then plug it in. But yes. And then your answer is going to be an x equals and a y equals. So when you're creating the parametric equation, you're actually finding the x equals equation and the y equals where they both have a t.